Welcome, everyone. How's it going? My name is Alex Corley. I'm a Senior Solutions Architect with Amazon Web Services. Been a customer since 2008. Been with AWS for the past 3 years. I joke that I come from a long line of startups, so a lot of iterative experience with services, different business ideas, different technical projects. And right now, I am in the SLG space and also tech lead for Justice Public Safety. So courts, cops, fire, and EMS, I joke, what we're responsible for. And today, we're going to talk about CJIS evidence management using GovCloud. So digital evidence management and digital forensics, secure offsite storage, and processing. So a lot of my customers come to me for a variety of reasons, right? It's not just cost economics, it's also security, scalability, the ability to share content with each other. For those of you in the law enforcement space, I am not a sworn officer, but I have been 10 fingerprinted and background checked, right? And so I work very closely with a lot of customers on these topics. And so a large majority of crimes that are committed today involve some sort of digital evidence, whether it's a cell phone, a laptop, a server somewhere, but there's portions of digital media that need to be included in the case management, the criminal investigation, and also the courts and law system. And so the digital forensics space right now is having some kind of human growth scale issues. Digital investigators are kind of hard to come by. They need to collaborate across the country, not just between departments. And a lot of times the digital evidence that's collected sometimes exceeds the size and capabilities of a local department, right? So if you seize a laptop or a large server that maybe has hundreds of terabytes of storage, local municipalities may not have the hardware or local facilities to be able to process these things. And so the solution that I'm going to talk about today hopefully will address most, if not all, of these concerns. So performance, compliance, and sharing are the major topics here, right? So performance is the ability to process things rather quickly. So a lot of these cases are time sensitive, and if things cannot be processed quickly, the case cannot proceed forward. And then again, sharing, so in between departments and investigators. So at AWS, we talk a lot about the undifferentiated heavy lifting. So we follow the NIST definition of cloud computing, the just-in-time delivery of IT resources via the internet in a pay-as-you-go model. And mostly my customers have been dealing with traditional physical infrastructure. So securing facilities, securing squad cars. And so that's where GovCloud and AWS come into play. We provide physically secure facilities to our customers so that they can start concentrating on other things, business logic specific to them that they need to focus on and not pay attention to, again, securing physical facilities. And then also I'm going to talk a little bit about how we're moving up the stack, not just the physical facilities, but also centralized logging, auditing, monitoring, and then also leveraging things like KMS for encryption at rest, and then modern cipher sets for encryption in transit, including FIPS 140-2 validated endpoints. So as I mentioned before, kind of coming from a long line of startups, I'm trying to bring automation to the public sector. Some of us call this DevSecOps, but I just want to point out some of these concepts before we dive into the actual architecture. And so all of this is the ability to automate, templatize, and version control your technical artifacts. The ability to codify these, and also enforce your policies. So just a couple weeks ago, we had, or I guess about a month ago, we had Lambda launch in GovCloud, and then just last week we had config rules launch in GovCloud. So this gives you the ability for near real-time remediation and enforcement of your policies inside of your ecosystem. All of these things kind of combined together we refer to as infrastructure as code. right? So again, version-controlled change management, the ability to store these durably and securely and track deltas as time goes on. It also allows you to share these artifacts, not only within your organization, but with other organizations, so that you begin to build repeatable, reliable solutions that can be run in any region, but specifically here we're going to talk about GovCloud. So what is GovCloud and what are some of the distinguishing features? It's a specific region within the AWS ecosystem that has network isolation and machine isolation from the rest of the regions. The identity and access management infrastructure is completely separate from our global identity and access management infrastructure. And then it has a completely separate set of API endpoints and console to interact with. I'm not sure if most of you are familiar with our kind of regular console, but it has a large geographic selection in the top right. So you can go from Virginia to Oregon to California to Australia. The GovCloud console obviously does not allow you to do things like that. It is restricted to the physically secure set of facilities and logical isolation that we've built. GovCloud is managed by US persons on US soil. So CONUS, Continental United States, is a popular topic that we discuss. And then it's also a community cloud, right? So in order to get a GovCloud account, you have to prove ITAR compliance. And as part of that, the account holder must be a US person, either a US citizen or a green card holder, or a US entity that's incorporated inside of the United States. And then also can handle export controlled data. So we check against the export control list before we delegate or instantiate these accounts for our customers. I want to spend a little time talking about the shared responsibility model. It's very important to really understand this. I know Brad went over a lot of this in the HIPAA high trust kind of talk that just occurred. But I want to spend some time kind of deep diving into this because it's very important. Just like HIPAA, a lot of my customers kind of assume that if they instantiate a GovCloud account and install or run their application within the architecture or the infrastructure, that they're automatically CJIS compliant somehow. Just really want to point out that the CJIS security policy for AWS applies to the cloud service provider. So that's going to be the bottom portion of this shared responsibility model. For our foundational services like compute, EC2, storage, which is S3 and our elastic block storage service, databases, our relational database service, so MySQL, MS SQL, Oracle, and then networking, so the virtual private cloud, the direct connect, fiber interconnect between facilities. All of these are managed by AWS, and we work with our third-party auditors to ensure compliance for shall statements within the CJIS security policy. And we have a control matrix mapping document that we can provide to you as a customer as part of our CJIS workbook that clearly delineates for each shall statement in the compliance regime, whether it is an AWS 100% managed control, a shared control where we maintain the infrastructure as a service or platform as a service, and then the customer is responsible for correctly configuring those services, or whether it's a 100% customer responsibility, namely something inside of the operating system that we have no visibility into or no access to. And so it's the customer's responsibility to kind of handle those controls and the implementation. Again, the CJIS workbook provides implementation level guidelines on this. And then a lot of my customers reference some external industry standards. If any of you are familiar with the Center for Internet Security, they have a set of benchmarks, both for the AWS core foundational services and also a 3-tier web application benchmark. So it's essentially a hardening guide that you can follow within your organization to configure your infrastructure and application to be best practice hardened. So the demonstration architecture that we're going to talk about today is a 3-tier web application. And I just want to go through kind of the flow here, and we'll talk about some of the supporting services. So the outer box there with AWS, I really want to point out that is the physically secure location according to the CJIS security policy. It has a FIPS 140-2 validated endpoint boundary around it. So whether you're calling the EC2 service, the S3 service, or you're connecting a VPN from your on-premises physically secure location to our physically secure location, all of that will occur at the boundary of the region. And so for this example, we're discussing forensic images. These images are kind of an anomalous term. These could be machine images, disk images, phone images. They could actually be kind of JPEG, visual images, but also audio recordings and video recordings, really any binary data that you want to durably and securely store or kind of fall under that category. The example application that we've developed here as a proof of concept, we did in 2 days of developer time. It was essentially building and configuring AWS services to cooperate in a compliant manner. So I just really want to point out kind of the agility here of being able to proof out some of these ideas. And then I also want to talk a little bit about the cost of this. So just some basic costing on this was right around $200 a month plus storage. And so obviously your storage will vary depending on the size of your organization and the amount of historical data that you have. But the compute and the database that will support a relatively large organization kind of falls under that category. And so really what this is a basic web application that triages API calls for the customer so that they don't have to do these kind of individually on their own. Images are stored in S3, which has 11 nines of durability. It uses AES 256 encryption at rest using the KMS service. This could be customer managed keys or AWS managed keys. And then we also do temporary access credential delegation. So we use the simple token service for least privilege separation of duties interaction with these. So I'm going to go into a little bit more detail on that in some later slides. But again, least privilege separation of duties is pervasively kind of built in throughout this infrastructure. So we're running this using Amazon Linux. We recompiled SSL to be in FIPS mode. You can also do this with Red Hat Enterprise Linux or Windows. Sometimes you can put the entire operating system into FIPS mode. Kind of depends on the level of rigor that you'd like to apply here. We did the SSL library so that Nginx and all of the supporting services built on top of that will leverage that. And then we have a MySQL database in the background that's both encrypted in transit and encrypted at rest so that we could build a metadata store that you could actually include CJI in so that you could do indexing and searching on CJI. So this might include names, case numbers, things like that. And then we have a number of supporting services to enable a lot of the secondary shall statements that traditionally have fallen within the customer responsibility model, but we're providing a best practice example for these. Some of those are kind of watching for failed login attempts. And so we ship all logs from this machine, operating system, application level, and you can even combine these with CloudTrail logs. So any API call into the AWS infrastructure, any access to the web application, any access to the operating system are all centrally logged in a central repository. Very simple kind of Twitter bootstrap UI here. But as you can see, we provide a drag and drop ability for customers to either with their phone or thumb on a managed device, or maybe back at the department using a laptop They can take files either from their existing body cam, dash cam solution and insert these into the system, or maybe they can use it with confiscated devices, right, that they're doing block level copies off of. I want to point out a couple things here that are very important for the chain of custody and integrity checking of evidence. So S3 supports MD5 hashing of objects before upload. So the application actually performs a hash of the object locally and then verifies that hash on upload so that we get a chain of integrity checking throughout the system. A little bit of kind of basic browsing and sorting ability, and then some basic analytics for things like file type distribution, case number distribution, officer distribution. So just some very quick visual analytics so you can kind of spot check what's going on within your digital evidence management repository. I want to kind of deep dive into a lot of the technical details here. So I've been saying least privilege separation of duties. Again, this is not only at the application level, but the network level. So as you can see here, we have a 3-tier web architecture with a load balancer, a web application, and a database. And so the routing rules, the security groups, and the network ACLs are all configured so that the internet can talk to the load balancer, but the load balancer, or things in the DMZ where the load balancer live, cannot talk to the database, right? They can only talk to the web tier. And also the web tier is only allowed to talk to the database, not anything else, right? So we've kind of built in these least privilege separation of duties at a network level. And as I mentioned before, using the simple token service, the uploads and downloads use temporary credentials. So when you upload a file, you have write-only permissions specifically to the folder namespace that those artifacts live in. And then when you download those files, you have read-only permission. So that kind of cuts out a lot of the entry points or potential kind of issues that you could encounter with maybe lost authentication tokens or reshared links, those types of things. We put expiration times on these. You can even use kind of one download and then the link is no longer valid. And then I also want to point out a couple things about our security groups. A lot of people don't understand that these are firewalls. They're by default deny all, and they are stateful. And so the CJIS security policy actually requires stateful firewalls, and then again, deny all by default. So we try and help customers as much as possible not make mistakes. And so instead of having a completely open firewall that you have to lock down, we actually take the inverse approach where you have to explicitly allow port access, whether it's 443 for TLS or maybe port 22 for SSH. I want to point out that all of this is codified in CloudFormation templates. So this is a JSON example for the read-only policy. It essentially allows get object access to a specific bucket namespace. And so this one is CJIS storage, but you could have a bucket per department, per investigation, per investigator, or maybe kind of the data governance lifecycle policies for data retention. So murder cases need to be stored indefinitely. Some felonies need to be stored for the duration of incarceration. Some things maybe don't need to be persisted at all because it was an innocuous traffic stop that did not result in any action. So just some details on some of the things that I've been talking about. So our load balancers use TLS 1.2 with modern cipher sets. KMS does AES 256 encryption at rest. I've mentioned FIPS 140-2 a few times. There's also FIPS 197, which covers data encryption at rest. That essentially is AES 256. And the CJIS security policy has a clear exception for FIPS 197 encryption at rest. So I just kind of wanted to point that out. And then also the FIPS 140-2 validated endpoints. Again, these are all of our API endpoints, as well as our VPN termination devices. The AWS GovCloud is a physically secure location. It has an ITAR boundary around it. And then I also want to point out that it supports FISMA high data classification levels. So just to kind of continue to deep dive on some of those previous points, CloudTrail logs all of the API actions from the cloud service provider level. So this is a console login. It's an instance launch, an instance terminate, a security group rule change. All of these are logged through CloudTrail. And then you can use things like config to track the deltas between those. So if you see in CloudTrail that you had a security group rule changed, you can go to config and see what that change was, who performed the change, when they changed it, and you get a nice little timeline view of your resources as they go through time. S3 allows you to enable bucket logging. And so all of the get objects and the put objects that are occurring for the storage and retrieval of the digital evidence is all logged through S3. Again, through CloudWatch logs, it all goes to a central repository. And then multi-factor authentication. So these are physical tokens or virtual MFA that you can apply at the account level and the service level. So we can do things like disallow deletion of objects unless an MFA token exists. You can also develop kind of dual key turning scenarios for different kind of access patterns, where maybe one party has the API keys and credentials, the other party has the MFA token. So both of those parties need to get together in order to delete or access information. So I want to talk a little bit about S3 and some of the storage options. Because the data retention policies do vary depending on the type of evidence. And so S3 and Glacier can be used together using lifecycle policies so that you can tier your storage for economic benefit. So standard is for active data, right? You know, you can read and write in real time with no latency. Infrequent access is more of a usage pattern design. So this is more the case of, I may need it within a few months, I may not, but I'd like to keep it in S3 because when I do need it, I want to get it immediately. And then these can also be archived to Glacier for long-term storage. This is 10 years, 100 years, right, kind of compliant long-term archival storage. Just want to point out the lifecycle policies that you can configure. This particular example has the whole bucket selected, but you could essentially have folders or namespaces within your bucket for different data retention policies. And then you can apply these policies at a namespace level. So this shows kind of how you can transition between different life cycles. This example uses 30 days for infrequent access, and then after a year, archives to Glacier. For this example, there's actually no deletion, but if you did have confidence in your data classification and data retention policies, you could automatically cull or reduce your data size as time goes on automatically. I want to spend a little bit of time talking about VPC endpoints. Previously, when I kind of ran production AWS infrastructures, in order to access S3, you'd have to have a public IP address on your instance, or use a NAT or some sort of gateway in order to access S3 using a private IP address. Those things are no longer the case. This is very important for things like the FIPS boundary, right, for the physically secure location. When data leaves a physically secure location, according to the CJIS security policy, it must either be encrypted on premises before it is transmitted, or it must be transmitted using a FIPS 140-2 validated kind of pathway, if you will. And so what the VPC endpoints do is keep all of your data inside of the GovCloud region, right? So from inside of your VPC, you can talk directly to S3. You can control access both from the VPC and the bucket level. So you have bi-directional permissions that you have to establish in order for access to be granted. And this can be done, again, at an individual VPC and bucket level. So if you have multiple VPCs for different reasons, you can kind of mix and match these access control lists. This is an example of a VPC policy. And so what this does is it allows get and puts from a VPC to a specific S3 bucket, right? So this is one half of the bidirectional trust relationship that you set up. And then this is the other half. This is an S3 bucket policy. So you apply this at the bucket level. And so again, bidirectional authentication mechanisms and access granting need to occur or can occur for these secure pathways to exist. Again, all of this is codified in AWS CloudFormation. So I do everything in JSON, but we've recently added YAML support. YAML allows commenting so that you essentially have a self-documenting automation artifact that you can leverage. These can be version controlled and shared within and outside of your organization. And really, this is kind of treating your architectures as the physical kind of concrete that you previously would have done with your data center. You can now codify these into a template, right? So instead of running physical wires between servers, you can now essentially write some glue code, if you will, to join VPCs or to join VPNs together. And then also you can define your subnet security groups, even your identity and access management policies inside of these templates. You can use these templates to modify your resources, and you can keep all of these in a centrally managed repository. So configuration management, change control, if you do ITIL type processes, all of these will fit within the tool set. You can organize these by layers, so nested stacks, or you can use separate templates that reference each other. And so these could be for layers of your stacks or for environments. And so a popular thing that my customers do is separate the security group roles or rules into one template, and they allow the InfoSec team or the network security team to manage that artifact. And then that can be included in a template that the developers use, right? So the control of the firewall rules and the network paths are separated from the actual developers so that they work within an existing kind of best practice controlled environment. And then you can also scale this out horizontally. So you can use the same template for each investigation. Some of my customers actually spin up an entire AWS account per investigation so that there's no logically shared resources between things. Kind of gives that levels of isolation. And then you could have maybe an environment that you keep forever, right, for long-term retention of things. But these can be stood up and tore down within minutes. So a lot of kind of ability there with the agility that you can have. Again, nested stacks for reusability and specialization. So this particular one has Department 1, Investigator 2. You could have a template, again, per investigation that includes the standardized security rules from the InfoSec team. You can use these templates to apply service-oriented architecture. So not just separation of duties, but separation of function. And so for this particular example, Agency 1, Vehicle 2, in Texas, the police vehicles are physically secure facilities. Or by department, by investigator. You could maybe ingest social media, tie in with your CAD RMS system, or maybe link back to legacy on-premises databases so that you could leverage our business intelligence and analytics tools against your existing data store. Again, multi-factor authentication helps prevent unauthorized access, so you have to have both physical possession of a device and logical possession of authentication credentials. This can be applied, again, at the console level, the API level, and then using the simple token service, you can apply it at the application level as well. I want to talk a little bit about the physical security of our data centers. We've been building physical facilities for quite a while now. And I just want to point out a few of the important attributes that might differ from legacy kind of on-premises configurations. So all of the access is controlled on a need-based kind of philosophy. It requires a trouble ticket to kind of grant temporary access, very similar to the simple token service example in the application. All access is logged and reviewed. There's separation of duties between physical and logical. And so people with physical access to the facilities do not have logical access to the services, and vice versa. This is applied at an availability zone level. So employees that work in availability zone A do not have access to B or C, right? So you can begin using these concepts to deploy your architecture and configure your architecture in a separation of physical and logical, right? Because some of those ideas come into play with the CJIS security policy. And then storage device decommissioning. So the security team keeps a keep it simple approach. And so physically, with your eyes, you can't tell whether a hard drive has been degaussed or not. So we hole punch or shred these devices. They never leave the facility. We don't store information on tapes that are off-site backed up, right? So you can have confidence that all of this remains within the boundary of the physically secure location. So some of the next steps where we can kind of take the logical conclusion of the launch of some of our new services, everyone's talking about machine learning. So I just want to point out that recognition was just launched in GovCloud last week. So object detection, scene detection, facial detection for still images. So the digital evidence management platform here, if you were storing static images, you could now begin to apply kind of automated metadata to the system. So instead of the officer kind of at the end of their shift going through and keying in from their memory metadata that was associated with the event, we could use automated processes to begin to apply labels to these things, right? Was there a vehicle in the image? Was there a person of interest in the image? And then also wanted to talk a little bit about Lex. So a lot of my customers have audio recordings of interviews or different things that they literally have to hand transcribe at the end of their shift. And so we're doing a lot of work now to kind of help reduce the burden, the undifferentiated heavy lifting of the customers, so that we can do automated transcription of audio files. In addition to this, kind of some neat things that we're working on. If you're not familiar with the DOT that is backed by the Alexa voice engine, that actually fits in the cup holder of a car. And so we can now start to build smart systems in a hands-free manner so that officers can begin to, in real time, add metadata or time series kind of metadata to a data store, so that while they're in the vehicle, they can do things like trigger an action word for kind of the type of incident that occurred, and that will auto-assign a timestamp. And then you can begin to correlate these things after the fact, right? So if you know a video was kind of filmed within a particular duration, you can begin to correlate these voice actions and the metadata associated with them with those videos. So data classification is one of the biggest problems my customers face. And these kind of concepts can help reduce the burden of data classification and really give officers more time to protect and serve as opposed to transcribe or do other kind of menial tasks. And so I just kind of wanted to talk a little bit about the future of policing before I left you here today, because there's a lot of opportunity, I think, for leveraging machine learning and other automation to keep our officers safe and help them kind of do, what they need to do, again, protect and serve. And so that's really what I had here today. I know it's the end of the day here, and so I'd like to give everyone a chance to maybe do other things. And so I'll be here with questions if you'd like to come up and ask questions. Thank you very much.